Welcome to this model. And this model we are going to see about HDLC. HDLC means High Level Data Link Control. It's a bit-oriented protocol for communication over point-to-point and multi-point links. So it implements the ARQ mechanisms. HDLC provide two common transfer modes that can be used in different configurations. And one is named as normal response mode and the other is called as asynchronous balanced mode. In normal response mode, the station configuration is unbalanced. We have one primary station and multiple secondary stations. A primary station can send commands, a secondary station can only respond. The NRM is used for both point-to-point and multi-point links. In asynchronous balanced mode, the configuration is balanced and the link is point-to-point and each station can function as a primary and secondary. And this is the common mode today. To provide the flexibility necessary to support all the options possible in the modes, the configurations are of three types of frames, that is information frames and supervisory frames and unnumbered frames. Now let's see one by one. Each type of frame serves as an envelope for the transmission of different type of message. Iframes are used to transport user data and control information. Let's see that format. Yes, this is the format. And S frames are used only to transport control information. So U frames are reserved for system management. Information carried by U frames is intended for managing the link itself. Right. Now let's see the frame format in detail. Each frame in HDLC may contain up to 6 fields. So as you can see in the diagram, beginning field, an address field, control field, information field, and frame check sequence field, and ending flag field. In multiple frame transmissions, the ending flag of one frame can serve as the beginning flag of next frame. Flag fields means the flag field of the HDLC frame is an 8-bit sequence with a bit pattern 011111110, and that identifies both the beginning and the end of the frame and serves as the synchronization pattern for the receiver. And the second field, that is address field, it contains the address of the secondary station. So if the primary station created the frame, it contains a to address. If a secondary creates the frame, it contains a from address. An address field can be 1 byte or several bytes long depending on the needs of the network. 1 byte can identify up to 128 stations. And larger networks require multiple byte address fields. If the address field is only 1 byte, the last bit is always a 1. If the address is more than 1 byte, all bytes but the last one will end with 0. Only with the last will end with 1, and ending each intermediate byte with a 0 indicates to the receiver that there are more bytes to come. The control field is a 1 or 2 byte segment of the frame used for flow and error control. The interpretation of the bits in this field depends on the frame type. And next is information field. It contains the user data from the network layer or management information. Its length can vary from one network to another. The frame check sequence is the HDLC error correction field, and it can contain either a 2 or 4 byte ITU TRC. The control field determines the type of frame and defines its functionality. And the format is specific for the type of frame. Now let's see each frame. So, iframes are designed to carry user data from the network layer. In addition, they can include flow and error control information. The subfields in the control fields are used to define these functions. The first bit defines the type, and the subfields in the control field are used to define these functions. The first bit defines the type, and if the first bit in the control field is 0, this means that the frame is an iframe. And the next 3 bits called N of S define the sequence of the number frame. And we can notice that the 3 bits we can define and with the sequence number from 0 to 7, since we are having 3 bits, right? So but in the extension format in which the control field is 2 bytes, this field is larger. The last 3 bits that are called n of r correspond to acknowledgement number when piggybacking is used. The single bit between the n of s and n of r is called p by f bit, and this bit p by f field is a single bit with a dual purpose. It has a meaning only when it is set and can mean pole or final. It means pole when the frame is sent by a primary station to secondary, or it means final when the frame is sent by a secondary to a primary. That is when the address field contains the address of the sender. In the prior case, when the address of the field contains the address of the receiver. Let's move on to control field for S frames. Right. These are the control field for P frame. Now let's see the control field for S frame. Supervisory frames are used for flow and error control whenever piggybacking is either possible or impossible or inappropriate. That is, for example, when the station either has no data of its own to send or needs to send a command or response other than an acknowledgement. S frames do not have information fields. If the first 2 bits of the control field is 1, 0, this means that the frame is an S frame. The last 3 bits called n of r corresponds to an acknowledgement number or negative acknowledgement number depending on the type of S frame. The 2 bits called code is used to define the type of S frame itself. With 2 bits, we can have 4 types of S frame. If the value of the code subfield is 0, 0, it is an RRS frame. This kind of frame acknowledges the receipt of a safe and sound frame or group of frames. So in this case, the value n of r field defines the acknowledgement number. Now let's move on to RNR. If the value of the code subfield is 1, 0, it is an RNR, that is receiver not ready. And this kind of frame is an RR frame with an additional functions. It acknowledges the receipt of a frame or group of frames, and it announces that the receiver is busy and cannot receive more frames. It acts as a kind of congestion control mechanism by asking the sender to slow down. The value of n of r is an acknowledgement number. If the value of the code subfield is 0, 1, it is a REJS frame. And this is a NAC frame, NAK frame, that is but not like the one used for selective repeat ARQ. It is a NAC that can be used in go back ARQ to improve the efficiency of the process by informing the sender before the sender time expires that the lost frame is lost or damaged. The value of n of r is the negative acknowledgement number. If the value of the code subfield is 1, 1, it is an SRAG S frame. This is a NAC frame used in selective repeat ARQ. And we can notice that HDLC protocol use the term selective reject instead of selective repeat. The value of n of r is the negative acknowledgement number. Now let's move on to the control field for U frames. The unnumbered frames are used to exchange the session management and control information between the connected devices. Unlike S frames, U frames contain an information field, but one used for system management information and not user data. As with S frames, however, much of the information carried by U frames is contained in codes included in the control field, and U frame codes are divided into 2 sections: a 2-bit prefix before the P by F bit and a 3-bit suffix after the P by F bit. And together these 2 segments can be used to create up to 32 different types of U frames. And the U frames can be imagined that U frames can be used for connection establishment and connection release. So if node A asks for a connection with a set synchronous balanced mode, that is SABM frame, node B give a positive response and with the unnumbered acknowledgement frame. After these two exchanges, data can be transferred between two nodes. So after data transfer, node A sends the DISC signal, that is disconnect frame, to release the connection. It is confirmed by node B responding with the UA, that is unnumbered acknowledgement. Now let's see some of the control command. SNRM is the set normal response mode. SNRME is the set normal response mode extended. SABM is set asynchronous balanced mode. SABME is set asynchronous balanced mode extended. UI is the unnumbered information. UA is the unnumbered acknowledgement. RD or disk is the disconnect or request disconnect. SIM or REM is the set initialization mode and request information mode. UP is unnumbered pole. RSET is reset. XID is exchange ID. FR MR is the frame reject. Thank you.